Yes, hi, this is George Lerakis again, and today I would like to discuss about physics problem solving guide. I know a lot of students when they see a physics problem or a question, usually they don't know where to start from, and specifically if that's for a final exam where you have all the material, so that becomes even more complicated. So I would like to show you some strategies that will make this easier. First of all, for every physics problem, in order to solve it, you have two parts. You have the part that deals with physics and the part that deals with math. So in the first part, what you should do, you should first read the problem and write what is given and what you are looking to find. Second, you can continue with a diagram that will help you to visualize the problem. And third, write down the formulas and equations that are related to the problem. In order to find these formulas, you will get help from the A, like what is given and what you are looking to find. So from that you will see, in which chapter, in which topic or topics you have to refer in order to find the formulas. The second part is the math part, where once you have written the formulas and the equations, the next step is to solve this system of equations and to add here on 1C one indication that you are going into the right direction is that you should have as many formulas and equations, actually as many equations as you have unknowns. So because that's the only way that we can solve a system of equations. The second step is you do everything symbolically. By symbolically I mean, you use, you don't put the values, the numbers, you just put letters, and you leave the numbers and the calculations for the end, so you don't carry that with you. And the final point on the math part is check the units. That's another indication that you have done the right thing. If the units that you get correspond to the dimensions, that means that most probably you have done the right thing. So these are the steps, and now let's go and do an example. So what's the example here? The example is that we have a car that is running into a curve of radius 200 meters. The curve is flat and unbanked, and the coefficient of static friction between the tires and the street is 0.3. So what we're looking to find here, we're looking to find the maximum speed the car can go without skidding. So that means without getting out of its path. Let's start with A. A, what is given? Is the R and the coefficient of static friction. And what we're looking to find? We're looking to find the maximum speed. So now for B, let's do a small diagram here. That's the diagram. This is the curve, this is the radius, and let's say the car is moving in this direction. And now here would do also something which is applies in a lot of problems in physics. So that's a free body diagram. So what we have, I mean, again, let's say that this is the curve. So what are the forces acting on the car? It's its weight, the normal force from the ground, and the force of friction. So I mean, the force of friction, of course, goes in this direction because as the car moves, the street exerts a force on the tires which are towards this direction. So that's for part B. And now let's write the formulas. So I mean, once you have this problem here, you see that here we have like this here refers to a circular motion. So that means that one thing that should get involved is the centripetal force, and of course the centripetal acceleration. And since you have these forces here, another thing that this problem involves, it's Newton's laws. So what we do, we go and we analyze the forces and we write the equations. So that's part C. In the y direction, what forces we have? We have the normal force and the weight. So since there is no acceleration in this direction, the sum of these forces have to be equal with 0. Now in the x direction, what force do we have? We have the force of static friction, and it's static. Why? Because of course the object is moving in the forwards, but the wheels that are here, the force of static friction, it's applied on the wheels. So the wheels in this direction, let's say here this is the curve and here is the center. So the wheels, the tires in this direction, they are not moving with respect to the road. So that's why we're having a static friction. So I mean, the force of static friction, as we know, is mu s. So that's the coefficient of static friction times n, the normal force, and this here has to be what? This here has to be the centripetal or radial force, and actually this here has to be the maximum, because for any value less than this, the car will be able to do the circular path. So this here is the maximum centripetal force, and of course the centripetal force is equal with mv square over r, and since we're talking about maximum centripetal force, this here should be V max, and that's the C part of physics, of the component that has to do with physics. And now we move in the math part. From the one we have that n is equal with mg, so that means that if you go here, you have mg times mu s, so that should be equal with centripetal force, which is equal with m v square max over r. So from that, if you solve for v max, you will have that this should be equal with the square root of mu s g over r. Of course, the m and the m cancel, where m is the mass of course of the car. So and then finally, I mean, this is also the b part that we are doing it symbolically, which means that, you know, we don't put values yet. So until here, so now, you know, of course everything is given, the mu s, the g, which is the acceleration of gravity, and the r. So if you put everything here, and of course you put also the units in order to do the c. So I mean, this is 0.3 the mu s, 9.81 is the acceleration of gravity, and 200 meter is the radius of the circular part, and of course the units for the acceleration of gravity, it's meter per second square, and of course the distance is in meters. So if you do all this and you get the square root, you get 24.26, and here you have meters times meters is meter square over second square. So with the square root you get meters per second. So the units agree with the dimensions, because you know, like speed has to be in meters per second, which is distance over time. So that's how you tackle problems in physics. So thank you for taking the time to view this video, and I hope you find it useful, and bye for now.